Hey guys, how we doing today? This is Mr. Martinez back with another video in our Get Me to High School series. This is going to be the start of a mini series though, where the videos should be relatively short. I'm going to try to make them between 5 to 8 minutes. So once I start on the next slide, it should only be 5 to 8 minutes or less. Okay? So let's go ahead and start with this. This is a sixth grade topic, and let's look at what Albert Einstein has to say. He says that energy cannot be created nor or destroyed. It can only be changed from one form to another. So that's going to prepare us for what we're learning today, which is energy transformations. Here we go. Okay, first thing we need to know is that all energy, okay, is divided into two categories. Kinetic energy, which is the energy of motion, things that move, and then potential energy, which is the energy of stored energy. This could either mean based on its position, how high up it is, or it could mean stored energy like chemicals in food, like molecules. Later they'll be broken down and they release energy. So let's go down these categories real quick and we're going to move on. So if you see mechanical energy, think of the M standing for moving. So that means something is moving. It's the motion. Electrical energy also moves. It goes like in the telephone wire right here, it goes from one place to another. So if you see electrical energy, it's dealing with electricity. Thermal energy, it's the vibration or the movement of those particles. It deals with heat. Okay? Radiant energy deals with what the star gives out. Okay? This is radiation. So we call it radiant energy, and it moves, travels from the sun to us. And then sound energy, those are sound waves. You hear something far away, the sound waves will travel to you, and then you hear it a little bit delayed. So that's all in motion energy. Moving over here to potential. Potential energy is stored energy, so you can have stored energy in a battery. We call that chemical energy. It's stored in the chemicals. If you open up a battery, there's some chemicals in there. When those chemical reactions are finished taking place, you have no more juice in the battery, and the battery's dead. You got to buy a new one. Food has chemical energy. This is all energy that's stored. Nuclear energy is what takes place when atoms are being squeezed together. So this would be like inside of a star, not the outside, but the inside. Gravity is also potential energy or stored energy. It's based on position, how high something is, something drops, right? Based on its placement. And then elastic energy. So this would be like someone holding a bow and it's stretched really far, or you pull a rubber band back really far. That's all potential energy. All right, moving on. Okay, here's just another breakdown of the energy. We're going to go through this pretty quick. So thermal, we said, was heat. So it's heating food, it's melting ice. Let me pick another color here. Electrical, we said, is electricity. So that's power lines and outlets. That's also lightning. Electromagnetic is going to be something we didn't get to cover this year, but you'll just need to know how to read an electromagnetic chart, but they usually don't test on that. So all you need to worry here is it's wave particles in the form of visible light or a radio wave or a microwave, things like that. They say the word wave in it, it's kind of talking about that. Chemical, let's get another color here. So chemical energy, stored energy in the compounds, in the molecules. So battery has chemical energy, food is chemical energy. What happens when you're talking about stuff inside of a star? Well, now you have nuclear fusion, which happens in stars, in the core of stars or in the core of planets, right? So nuclear energy, is dealing with atoms being squeezed together. And then the last one is moving energy, which is mechanical. So think of M, mechanical, moving, and that's hammering a nail or a moving car. All right, so let's see if we learned this concept. Let's try some practice questions. Okay, here's a star question. We're going to do this one together, and then the next couple questions, I want you guys to try on your own and then check back with me. So let's go ahead and start by breaking down the information. So a student builds a circuit. The circuit has wires that connect a battery. So here's our first important piece to a switch and a fan. Which energy transformations happen when the students close the circuit and the blades of the fan begin to spin. So basically, we need to identify what's going on at each one of these steps and just figure out which answer has the correct energy transformation. So let's look at the first one, a battery. I just taught you this in the previous slides. A battery would be what kind of energy? Well, battery stores chemical energy. Okay, so let's talk about a switch. So if you go to your house or your apartment and you flip on a switch, if you have power, whatever you flipped on will turn on, whether it's a light, whether it's a like an air fryer, or whether it's a blender, uh, alarm clock. It doesn't matter. If there's power and you flip a switch, it'll turn on. So we're going to say that this is electrical energy because you paid your electricity bill. And then the last one is a fan. Well, what do we know about fans? We know that the blades are in motion. If the blades are in motion, they're moving. If they're moving, we call that mechanical. Yes, it is also known as kinetic energy, but kinetic energy is a broad term, kind of like saying car. Well, if we want to know a specific car, we don't say car, we say, two-door car, like a coupe, or we could say like a Suburban or a truck or something. You'd be more specific. Okay, so which one of these actually has the right answer? Well, we have to start with chemical, so we can eliminate G. We can eliminate J. Then we go to electrical, which would be next, so we can eliminate F. Let's just make sure. Then our last one would be mechanical. That means that our answer is letter H. Let's try another one. All right, moving on. So the blades of a wind turbine, I'm talking about blades again, this is just a big fan, are at rest until the movement of air causes the blades to spin. Okay, and you can see resting right here, and you can see spinning, and this is a wind turbine. Which energy transformation happens when the blades are spinning as shown? Go ahead and pause the video and try to do this on your own right now. Okay, welcome back. Let's go ahead and see if you got the right answer. So if the blade is resting and then it starts to spin with the air, okay, that means that, what are we looking at? Let's look at our choices. F, is it going to be electrical to mechanical? Is there any electricity that starts this whole process? Well, no, because the air is what moves the blades. So we can eliminate F. So chemical energy to electrical energy. So is there any batteries here? Is there any food here that we're using? No. So we can eliminate G. Sorry. Mechanical to electrical. Okay, mechanical means moving. We know that when the blades are resting, nothing's happening. But when they are moving, that would be mechanical. So that part is right. And why do we have the blades moving? So that they can generate electrical energy for a city or for a farm or for something, right? That's whoever put the windmills there, they're going to use the energy, okay? And then the last one, chemical to mechanical. No, these are not being powered by batteries. That would be chemical. So your answer by default has to be H, okay? So we're going to be resting. There's nothing happening here. And then once it starts to spin because of the air, you have mechanical energy, and that gets converted into electrical energy. Okay, next one. All right, the main parts of a working clothes dryer are shown in the diagram. Okay, we have an outlet here, we have a motor, we have a heating duct, and then we have the drum where the clothes go. Okay, this appliance dries clothes primarily by converting what? So this is another energy transformation question. Go ahead and pause it, try this on your own, and then we'll come back. Okay, so let's see if you got it right. We're going to just run through the different stages here. So we know the first stage of energy would be electrical because it's coming from an outlet. Then you have to heat the clothes or else they don't dry. So this would be your second energy transformation. And then your final one would be the drum, which would be your third. And what happens in the drum is the clothes are getting tossed around. So we know that that would be mechanical. So let's see if that fits anything that we have here. Let's start off with A. Electrical energy, yes. To heat energy, thermal, yes. And mechanical energy, yes. So A would be our correct answer. But let's just make sure, let's verify that the other ones are not it. B, mechanical energy. Well, we don't start with motion. We have to be plugged in first. So B is wrong. C, electrical energy, yes. To heat energy, yes. And light. Well, there's no light being produced, so we're going to eliminate that. D, mechanical energy. Again, we're not starting with motion. You have to be plugged in first. Oops. So that would be wrong. The correct answer there is A. All right, next one's the last one, guys. All right, which statement describes the energy changes that occur when water in a tea kettle is heated on a stove that uses natural gas? So the first thing we're going to want to do here is let's circle this bottom part right here, and this is going to be our gas that powers the thermal energy for the stove. So gas, if you don't know this, is chemical energy. So we're going to start with that fact. Then we know that gas is going to heat up the water in the tea kettle. Okay, so the water is going to get hot, so that's thermal. And then the water is going to reach a point where it boils and it goes into a gas state, which is going to be steam. And when it does that, it's going to make a sound. It's going to whistle. It's going to, I don't know if you've ever made tea before, but it sounds a little something like that. Okay, so now that we've had this, why don't you go ahead and pause the video, see if you can answer the question. Okay, so let's see if you guys got it right. We'll start off with F. So some of the chemical energy in the natural gas transforms into thermal energy. Okay, well that's what we said, right? Which heats the water. Okay. Then some of the thermal energy, which is what we said, thermal, changes into sound energy, which is what we said, when the water forms steam, and then the steam leaves the kettle. Okay, so based on everything we covered, that should actually be our correct answer. Let's verify the other ones are incorrect by going through them, okay? G, some of the thermal energy of the natural gas transforms into sound energy. Okay, so we're skipping steps there, so that's already wrong. H, some of the electrical energy in the natural gas transforms into thermal energy. Okay, which causes the water to form steam. Okay. Thermal energy changes into sound energy. Okay. And light energy. Oof. Okay, so that's going to make it wrong. There is no light energy involved in this transformation. And the last one says some light energy, so we can already stop there. That is incorrect. So this should be the right answer, F. Okay, guys, that's going to do it for this mini series. Hopefully that was helpful. Log into Canvas, go to your do first, complete all the little assignments, and now it's your turn to practice, and then turn those things in. I'll catch you guys in the next mini series video. This is going to be one of several. Have a great day. We'll see y'all later. Bye.